So this project, we're going to be making a platform for a couple of compressors that are going to drive the automatic tool changer, or the ATC, on the ShopBot. I've got a number of rolling carts that I used, and I put the two compressors on top of the rolling carts, but the rolling carts are really expensive, and I happen to have some really nice casters that I bought for, I don't even remember what the project was. So, and I've got, shop grade plywood here. I've got MDF here. And plus, I want to do some special features to the platform in the sense of making the compressors a little more vibration friendly because of how I'm going to pipe the air supply. In terms of how the piping is going to run, I want to minimize how much vibration the tools will actually be feeling. So what we're going to do is take a look at what I've got, and we will begin drawing the platform that we're going to make to rest these two compressors on. Let's move on. So this is the project. We've got a couple of California Air 260 CAD 6 horsepower 20-gallon compressors. And when California Air advertises that they are quiet, they are. I think the decibel range is in the mid-70s, and they're really, really quiet. I ordered 2 of these because we're going to be powering not only a tool changer on the ShopBot, but we're also going to be powering our X-Air adjustable spot cooler. And on paper, one compressor is going to drive both of these on paper. I just don't believe it. I think the 20-gallon is far too small. Even though this meets the specs based on what ShopBot is saying, and I'll tell you, so far, when they say that something meets the specs, it really does. This ShopFox, I don't recall it might be a W1685, 1.5 horse. Really does the job. For the cost, 1,300 CFM, something in that range, does the job really well. So I've learned to really trust what those folks are saying. So I'm going to be piping these 2 items together, and what I'm doing here is I'm actually going to pipe them together so that I can run both of the compressors to power the ATC and the spot cooler if that becomes necessary, which I believe that it will. Or if it's not, I have the ability to run them both and do 2 things at once. So we're going to connect them, but then we're going to be able to run them individually. So I'll be able to run them together with a T that'll be here, going up to a pipe, and the regulator and filter and moisture remover that I bought, frankly, on eBay, what the gentleman says you want to do is run your pipe vertically, and that's the way that you're going to really help keep water out of the system, because I would dread the idea of running water into the ShopBot ATC. And when I tee the pipe off of here, I'm literally going to, when I get the compressors rolled over to where I want them to be, here, I'm going to run the pipe straight up to the ceiling, to the underside of the roof. I'm then going to run them down, run the pipe down. So I'm just going to run it vertically, and then come right back down and set my regulator here, most likely is what I'll end up doing, to really make sure I get no water. So the entire project is because I don't want to use up my good rolling carts. I'm just going to make my own, is the bottom line. And I'm going to enjoy doing it, I believe. So let's move on to tool pathing, what I'm going to end up doing. So let's do that now. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. So I think what I'm going to end up doing is making the platform, I'm going to make it 2 inches thick. I want it to be robust. I want it to be long-lasting, and that's just what I want to do. Single-sided, so my width is going to be, I'm going to have it 36 wide and 30 deep. So I'm going to actually cut this to make it 38 by 38 for right. 38 by 32 is what we're going to make it. Now, the material thickness is actually something that I need to measure. I'm going to put my caliper on the three pieces that I'm going to use. I'm going to come up with something that it's reasonably actually, no, I'm not, because what I'm doing is cutting the three pieces individually first. So the first piece that's going to go on here is the MDF, because that's what I have on the table. So let's measure that. So my MDF measures 0.502. That's just what I'm going to leave it at. Inches, material surface is our Z0. Lower left for the XY datum, modeling resolution high. Got it. Okay, so, all right. So I'm going to want to actually cut this MDF at 38 by 32 because I'm going to do a final trim. There's going to be three layers. A piece of 3/4 plywood, then MDF, then another piece of 3/4 plywood. I'm going to cut all three of these pieces to 38 by 32. I'm then going to glue them together, and then I'm going to work this 2-inch piece on the machine, is what I'm going to do. So that's why we're doing this. So 38 by 32, I'm going to give myself guidelines relative at 38, create, close, guideline, okay, relative at 32, create. Okay, close. Now I can draw a vector. Yeah, let's draw a rectangle. Anchor point 0, 0. The x is going to be 38, and the y is going to be 32. Apply. Okay, so what I want to do is actually move this to a new layer. Let's copy the new layer. And we're going to call it MDF perimeter profile. Okay. Now let's pull up the cam side, and our vector is selected. Profile. Start at the top. Cut depth 0.522. That should be okay. A little bit shallower than that. 1/2-inch end mill is still in the tool from the last job. Still cutting MDF. Clear all passes. Make it 4. Set passes. Okay. Conventional. Outside on the right. Ramp. Calculate. 1 duplicate vectors are identified in the selection are being ignored. There are 1 remaining vectors. Okay. 1 closed vector. Yeah, not much to see there because of what we're doing. Yeah, we're just going around the perimeter. Okay, so not much really to see there at all. So, yeah, that's going to be fine. All right, close. Okay, so let's cut this piece, and then we will move on, and we will cut the 2 pieces of 3/4 plywood is what we'll do. So I'm going to zero the machine, and then I'm going to air cut this just to make sure. And then if everything's good, we'll pick it up watching it actually cut.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
So everything looks good on the air cut. It's going to turn on all the power now. Okay, so the next step in the process is we are going to create the tool path for cutting our 2 pieces of 3/4 cabinet grade plywood. So I've got a 4x8 sheet of plywood on the table on the tool. So let's change the setup for this. Width. Yeah, okay. That algebra worked. Yeah, nice. Okay. So let's measure a couple of things here. So our material is 719 thick, single-sided, material surface, lower left. Okay. So we are on layer 1, which is where I am creating the work before moving it to its own layer. So this vector is 38 by 32. Okay. Let's copy this. Let's paste this. Move it down into the lower right-hand corner. Anchor it to the lower right-hand corner. That should work. Close. Okay, so now what I should have are 2 vectors. Okay, yeah, that's what I want. I want to be able to take my sheet. I want to be able to yield 38 wide by 32, 38 on the X, 32 on the Y. So now the deal is the distance that's in here is 1/2 inch. That's the diameter of my bit.
If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video.
I'm thinking what we should be able to do is to select both of these vectors as profiles and have it trim them accordingly. So that's what the plan is. So the material setup was 38 times 2 plus the kerf. That's going to be left when the 1/2 inch bit runs through here. The Y is 32. The material thickness is 0.719. I measured that. Everything else looks okay. Now let's come over to the toolpath side, pocket. So I'm thinking that I've been cutting 15 thousandths and it's not deep enough. At least it wasn't on the MDF. The MDF wasn't perfectly flat over in this area. And it's no big deal, but I don't recall if we can do this. 0.719 plus 0.02 equal. Yeah, you can. Awesome. 0.7, so that's going to be 20 thousandths over. End mill is still selected. 3 passes are still good. Outside on the right of the line, we're using a compression bit. We'll conventionally cut this. I'm definitely going to want ramps because it's plywood. And this is going to be called plywood perimeter profile. Yep. Awesome. Let's. Okay. Right. It makes sense. It's not doing anything in there. So let's do this then. Let's bring a guideline right at 38 1/4. That's right in the center. Then let's bring a vector. Let's draw a line here, here. You see where I'm going, creating a second tool path on this. But I think what I'll do is let's get rid of these vectors. Let's draw let's create another vector. Give us this. on the line. Okay, not really doing much there. Yeah, okay, so that should give us exactly what we need. Those two tool paths together. Okay, so we should be able to run those two individual tool paths separately. So the next thing I'm going to do is zero the machine, zero the z-axis. I'm going to set the bit so that the dust skirt is correct. We're not expelling all that into the air like we did yesterday, cutting the MDF. And then I'll air cut these and we'll see what happens.
If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. But 15 thousandths was not enough. I'm going to stick with it because I've intentionally cut this wider than necessary. So now we're going to come over here and we're going to run the split right down the center. Look over here. Yeah, it got through over here because the material is standing up higher than it normally would be, and the vacuum's not holding it down well at the outside edge. But that's, I'm not concerned with it. But it didn't get through over here, though. I can see that. That'll be all right. Will it be all right? No, I'm going to recut that a little bit deeper. Is what I want to do. Perimeter profile cut. Close. I'll change that cut depth. 0.75. Calculate. Okay. And Control C. A little bit deeper. Save. Yes, we're going to replace the file. Let's run over to ShopBot. Same file, perimeter profile, no offset. that now. So what we've got here is two pieces that are 37.5 by 31.5, and I have to discover why that was the case. Still didn't cut through. I must have loaded and modified the wrong file. I should have air cut this first. The bottom line is this is going to be okay because I did plan these pieces to be larger than I needed so that I could do a final perimeter, a very final perimeter profile, exactly how I wanted them to be. So now the next step here is going to be to glue these three pieces together so that it will become my profile. That's literally the next step is what I'm going to do. Well, the next step, we're going to figure out what happened with our tool path. That's going to be the mystery that we're going to uncover, and then we're going to glue those together, and then we'll start tool pathing to make the proper sort of preparations I want to have for our compressor project. So let's move on.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, where we last left off yesterday was getting a size that we didn't expect, 37.5 by 31.5, I think. And I realized my mistake. I left it on the line. So that's why I'm a ½ inch off, because on the line is a 1/4 inch on each of all four sides. So a failure to check the tool path is what caused that mistake. It's okay. I don't have to recut the pieces because I am going to net these at 36 by 30. I wanted to do a very nice, clean final trim at the very end. And that's the bottom line. Moral of the story is, listen, if I'm not checking the tool path before I literally run it on the machine, you can expect there to be results that aren't what you exactly wanted. Okay, so I've got my three pieces cut. I'm going to glue those together. And after that, I'm going to make a I've modified the design in my head a little bit. And I want to be able to go about getting after that. And And yeah, that's what we're going to do right now. Let's make that. And what I've decided to do was create a skirt around the perimeter. So I'm going to have my three pieces of material, the platform, which are a piece of 1/2 inch MDF between two pieces of 3/4 plywood. But I'm going to cut three pieces of 7/16 OSB, and I'm going to then pocket underneath that, so I have literally a skirt all the way around. Yeah, drawing one. And what I mean by that is, yeah, this is a drawing from a prior project, my platform project. And I'm literally going to do the same thing here. So these are going to be my three layers. I'm going to have my plywood, my MDF, my plywood, and I'm going to have some OSB down here with the idea or the concept that I'm going to have my casters sit inside of this pocketed area and have a little bit of skirt around the entire perimeter. No particular no particular design requirement, except I think it's going to look mean. That's just the bottom line. That's why we're doing it. So I'm going to cut those pieces of OSB since I've got a mess around the tool, meaning I haven't swept up, and then we will get to gluing material. So let's do that now. Okay, we're going to make our skirt about 1.5 inches thick, 1.7 inches, well, probably 1 3/8 inches. And all that noise you hear in the background is just the spindle warm-up routine running, et cetera, et cetera. So let's make our project for let's cut our three pieces of OSB. I'm going to orient the material a little bit differently this time to take better advantage of vacuum hold down. Okay, so we're getting this vector drawn around the perimeter. Creates. Makes sense. Let's get rid of all of that. Get rid of that. Let's get a vector. So the X is going to be 32. The Y is going to be 38. And that's because of it's because I want to take advantage of the two zones on the vacuum hold down rectangular. I'm sorry, 0, 0. Width is 32. Height is 38. 3/8. Close. Okay, we should have a vector here. And we do. So let's job size 32, 38, single-sided. Material, I've measured it. Right. Now let's create a profile toolpath. Let's select the vector. Profile toolpath, cut depth 0.439. Let's see if that's deep enough. I still have my 1/2 inch end mill in the tool. Actually, I'm going to run the tool. I'm going to get the Z up, because when you disconnect the machine, I have been losing the Z, meaning the YZ carriage just literally floats down on me. So what we could do here is I'm going to go to 8,8,3 and just go to. That's going to bring me down, and then I'm going to have to zero it in all three axes. Okay, so while the machine is moving, we're going to focus back where our mistake was previously. Cut depth is 0. I'm going to 0 to the top of the OSB. I have my tape measure on there. Get that off the tool. My cut depth should be okay. I'm going to leave my 1/2 inch end mill. 2 passes. I'm going to want to make it 3 because I don't want to stress the movement, the piece, move it. So this time I corrected my prior mistake outside and to the right. Same compression bit. I'm going to ramp into it. No reason not to. OSB perimeter. Save C is 0.2. That's fine. Calculate. Okay, I may have created a duplicate vector by mistake. Edit, undo, delete, select the vector, racetrack. There are 2 vectors here. 2 vectors. Yep, okay, there were 2. Really handy to have that racetrack. That's what Chris Burns calls it. I've got 1 closed vector, good to go. Calculate. Yeah, we're going to cut through. All good. Looks fine. I won't bother previewing it, but I'm going to air cut it. So I'm going to zero the tool, air cut it, and then let's see what happens if all is well, and the next thing will be a GoPro. So I did have to make a small adjustment on where the workpiece was located because my scrap that I'm using for this is probably almost at the exact size I need. And I'm finishing a second air cut, and now we're going to run it and create in that.
Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.